So first off, a little bit of just like where are we in this thing? We launched the Kickstarter in August. And a lot of the work since between then and now has really been taking the prototype devices and turning them into actual things that are functional. And I'll let Nick talk about that most. We are now we've gone through a couple of iterations. We now have something that is generally good, and there's a couple of things that need to be fixed, and so we're continuing to iterate on the design. But in the meantime, the earlier prototypes there were definitely technical challenges that were not yet resolved, and so we've worked through a lot of the heavy lifting stuff on the hardware side, and then on the software side, plenty of work behind us, plenty of work ahead of us, and so in the meantime, as we get into the way that we're going to roll things out from now, we announced on our most recent update is this alpha, beta, gamma release, and so we're thinking about it like we have in the short run, we have a small set of units that are functional but are not going to be the final versions. There are problems that we are aware of that would cause us to not want to ship them in their current form. But we're going to select a few folks to participate with us in the development process, essentially. And so I know we got like 50 volunteers in the Kickstarter update. We only have 10 devices, so we will be going through and figuring that out in the next couple of weeks. This will go out in February. Then we have a beta run that is in March, where people can opt into essentially a pre-release device and agree not to get the final version, to get the pre-release version earlier. And we're currently planning on making about 250 of those. And then we have what we're calling the gamma release, which is the full release of the product, planned for April. So, and that's when all the like accessories and other stuff will go out too. So what we are also going to want to do is start to get more information and documentation and stuff out now that a lot of the design has been finalized. So that'll start happening in parallel. And also we're like eager to start what we think of as like the community engagement part of this, right? Where we haven't really had anything for anybody to play with yet, except to just post some updates and react to them. And we're going to get into the place where there's stuff to do and stuff to play with. And so we're thinking about how to manage that and how to best work with you all on making this a really killer product. And so if you have opinions and thoughts on that, now is this is a great forum to talk about that. Nick, you want to talk a little bit about state of development and also maybe some of the things that are on your mind right now? You talked about eSIMs as a thing that's top of mind right now, like things that you're excited about the product and some of the stuff you've discovered as you've gotten it up and running.
Sure can. Hey everyone. I've got a few things to do. I have a unopened box at the moment, which is our Kickstarter kind of everything all in one box that we were using to give to alpha testers. I can open one of those. I can show you walk through the desk and kind of walk you through one of the issues we're dealing with at the moment on the PCIe side and trying to figure it out. And point and show a little bit about the solid antennas. But generally, just stepping back to say I'm super excited about Tachyon at the moment because it's the Raspberry Pi that I always wanted. And I would say I don't know how many Raspberry Pis I've got. I think at one point it was 29 turned on. I should say during the holiday times, I live in San Francisco and my street is just fronted onto like a main road, whatever that is translated into US terms. But I put Raspberry Pis up to control various decorations around the house, like Halloween skeletons and stuff like that. So there's an excess amount of Raspberry Pis, and I'm a huge fan of them. And I think the problem I always suffer with Raspberry Pis is when they get a little bit too far away from my house, like in the tree outside, can't get the Wi-Fi to connect to my house, and I end up running Ethernet cables across the home to access extender points just so that I can get control of those skeletons in the tree, because of course I'm a control freak and need to be able to monitor if the skeleton's operating correctly or not. So with the Tachyon, I think I've become a fan. I'll just say that, and a user of it. And I know that's probably infuriating for folk that don't have one, but I'm just like, it's very exciting, and I'm enjoying it very much. Maybe I could just switch my camera to my desk and give you a view of kind of what does chaos look like. Where's the video switch? This is going to work. I'll put the filter on. There we go. Chaos. This is
Still
I guess,
somehow doing it to your keyboard. Oh, there you go. And it's gone.
I guess this is what having fun looks like if you're in the middle of developing Tachyon. And maybe I can use this as a way of just describing one of the two kind of problems we're seeing at the moment. One of them is with PCIe compatibility. You can see on this desk a very large amount of arbitrary PCIe devices. Probably my favorite one is the PCIe riser card that allows you just to plug in like desktop PCIe cards and connect it up to a cable to Tachyon. Eric on the call, Seth as well, has been working on this a lot longer than I have. I just went into my cupboard and pulled out PCIe accessories that I once thought was interesting enough to buy. And we've been trying to figure out why the PCIe bus is not reliable from the Qualcomm modem that we're using into both what's a proprietary specification. So Raspberry Pi have their own spec for the PCIe connector that comes on it, and they have the Raspberry Pi has a slightly lower spec PCIe bus on it compared to what's on this one. And then second, some of the behaviors of it. So on Raspberry Pi, you can plug and play all of these delicious hats together. NVMe drives, you can plug in Ethernet adapters. This one here is a USB PCIe card. There's a 2.5 gig networking card, a USB hat. This is one of the ones I've been trying to get working because I have wanted to just plug in a ton of things to do some power testing on it. And what we're trying to figure out is what is the precise magic needed to make the Qualcomm modem compatible with this PCIe standard. And we've been building these little adapter boards. This is the latest version to try to figure out what the exact tweak is that we need to do. And there's two PCI buses on this chip. One of them is connected up to the Wi-Fi and Bluetooth chip. That's another Qualcomm chipset inside here. That is working at an astonishingly fast rate. I think we were getting 700 and something megabits up, which I was very surprised about. Typically, you would expect to see that down, but we're seeing about 400 down, about 700 up. That is on Wi-Fi. This is a sub 6 gigahertz Wi-Fi, so it has a lot of bandwidth available. But on the PCIe side, we're having fun. For example, it enumerates, and then 95 seconds later, it disconnects because it was unable to change the power transition mode of the PCIe adapter. And we're just in the middle of trying to figure out what is the commonality between all of these things, because there's an electrical spec that it looks like we're passing, but there is obviously some very small tweak needed on one of the pins in some way. Is it a timing issue, or is it, I don't know, maybe it's timing, maybe it's just the boot up sequence. I don't know. Suffice to say, this is a good snapshot of development. And while I'm pointing at it, maybe I'll just dig into the teething issues. I mean, it looks like I've got many Tachyon devices on my desk, and you would be correct. Although I can only see three at the moment. Here's the original and the OG one.
Nick is just hoarding the Tachyon. So everybody who wants
I
theirs and
mean,
doesn't have
that
it,
is very true. Guilty of charge. This is the original Tachyon without its stickers and its shields and no antenna on it. The antenna version of it here, I think in general the antenna is behaving extremely well. But there's one caveat, and that caveat is probably one that we're going to have to work through. But before I jump to antenna, you can see like there's I don't know how the zoom works on this thing. I don't even know where the camera is. This is a power connector. It wasn't soldered on properly. There's a dry joint on it. So one of the things that we need to do is run this through our SMT profile in the factory that we're using quite a bit more. and analyze some of the X-ray data. This is one of the most dense boards I think Particle's built. In our time, we built, we built, I don't know how many unique pieces of hardware into the hundreds. But the density of this and the weight, and the cost of it as well, just in terms of like the raw materials and things, is one of the most complicated ones. And so it's going to take us, after Chinese New Year, which is when the factory shuts down for the time being to do everything it does. When they come back, we'll be rerunning this, trying to figure out what the exact flow rate is for the PCB in order to make sure that everything sticks to it. And maybe I'll just jump to the antenna and then I'll happily do an unboxing as well. The antenna side of this, I'm in my basement, which is why it's dark and dingy. Also cold, which is why I'm wearing a lovely jacket, winter jacket. The antenna we got on it here doesn't really connect that well down here. I'm in San Francisco. You would have thought that that would mean you got blazing fast 5G. It's true if you're in like one of 20 spots, but there's so many people here trying to do so much 5G that in general the cellular connectivity is very variable in terms of like getting true 5G plus down. And this antenna at the moment is connected to T-Mobile. You can see on it there's this LED. It's probably the color of the light's not going to be able to show you what it's glowing green at the moment. Typically, it should glow cyan to show that it's connected to the cloud. And it's disconnected at the moment, partly because I just picked this thing up, and that's how sensitive we are on T-Mobile at the moment. So right now, I think on band 71, which is the urban low band extension for T-Mobile, which just happens to be the only one out of the antenna that I think is 6 dBm lower than we'd like it to be, is probably the one that's being used right in my basement, and it's also causing a drop just in here. So unfortunately, it's penalizing me. If you're in the rest of the world version, there's no bands impacted at all by that. So if you look at this antenna, one of the pieces of work we are doing is this is currently a flex PCB. It's stuck over the top of this plastic extrusion. It's just there's a mold for this, and the technology we're using is actually a technology that uses a laser to etch a pattern on a certain type of plastic, and then we put it into a bath where it will get plated with the metal, very thin metal layer to generate itself the antenna pattern. So we're kind of cheating at the moment. We're using a flex PCB, which is a pretty good approximate. But the thing that we need to do next is just do one more tweak to this design to try to figure out how we can remove that band 71 dip. And very transparently, if anybody's ever done antenna work, there's a bunch of theory you can do on this. There's a bunch of practice. There's a bunch of monkeying around. And what is needed here is arbitrary monkeying around. We have a simulator for this antenna, so you can determine what the radiated pattern is going to be when you make changes to it. It has a model of tachyon inside it. And we're going to monkey around with that until we've both emulated band 71 dip and then found what tweaks to the pattern we can do that increase that. And somebody's going to go and sit in a room until that's fixed. And those are two examples of things that we're working on at the moment. So the quality is like the operation of it's feeling great. The quality of the product good. The excitement's very high. The details, right? I think the details do matter with this. And as I'm penalized personally on that band 71 issue, we're going to fix that. And on the PCI thing, these toys won't play with themselves. So we need to go and make sure every one of these can be plugged in at least once so that I feel I have invested in a horde of PCIe things without purpose. Great. Zach, I can jump through an unboxing, but maybe you want to switch topics and
Yeah,
then
I'll pull up. I mean, I think I'm sure we'll want to do an unboxing here. So why don't, but we'll take a break for a second just to see if folks have questions. I'll answer one that's come in. If you do have questions, feel free to, again, either, I'm going to take I have to switch the spotlight onto me, replace spotlight. There we go. Okay. Um, uh, we'll take some questions and then go back to the deep dive. I like arbitrary monkeying around as like an engineering stage, which I think is a good description of the part where you get it and it's supposed to work and it mostly does work, but sometimes doesn't work. And getting a product that we're excited to ship requires that it just work. So, and I had one other thing I was going to share before we do questions. You said the original Tachyon, because I was like, oh, you know what? We had this. I think of this as the original Tachyon, which is I don't think anybody's ever seen these other than like probably some of the particle folks. But the prior idea behind the product was something that is uh, was not as well, wasn't as powerful. It had a less powerful chipset behind it, but also wasn't yet in the Raspberry Pi form factor. So this is an earlier version where we're sort of thinking about what this product would be, uh, and um, and I think realized that in order to make this thing useful, we really wanted to embrace the Raspberry Pi uh, design such that we could make it compatible with all of the accessories and hats and things like that that exist in that ecosystem, because there is such a healthy ecosystem available of all that kind of stuff, um, which then means we need to make sure that it's compatible with all those things, because otherwise, the what is worse than being purposefully incompatible is being accidentally incompatible, where we attempt to create compatibility, but then it doesn't work with a variety of things for you know complex technical reasons, right? I'm going to answer this question that Lance posted. Any future where you see the particle dashboard send reports from eSIM, webhook status, battery quality, etc., data that could be sent to AI agents to monitor, but also provide insights about your devices and if they're dying in some way, or noticing certain firmware works better in the same region to help with A/B testing, etc. So, Nick, I don't know if you want to use it as a jumping off point for talking about some of the cloud backend stuff, which we talk about a little bit in the Kickstarter campaign, but haven't really been focusing on the updates. And what are some of the things we're intending to deliver to folks alongside the device?
Surely can. I'm wondering whether Julian, give me a shout if you have the ability to screen share where the console is currently right now with one of the SSH sessions inside it. I think that might be super interesting.
Oh yeah,
Uh,
that's a good idea.
Um, if you want to just ping in the chat, Julian, if you can do that, no worries if not. I don't know what account I'm logged into at the moment, otherwise I'm going to take a look. What I was going to say is, yeah, we're in the middle of developing the cloud side. In fact, that is precisely what most of the team are currently working on. Two components to that. One of them, the onboarding process. How do we get the device registered? How do we get it auto connect into the cloud, which is one of the two steps we normally do. And the third step is how then to get it ingesting data into our cloud platform automatically, so you can monitor and observe the device. Because stepping back, Particle's an IoT platform for developing your connected products. And predominantly, one of the things we do is we serve that up through our cloud platform, which has a console to it and the ability to observe your fleet. And we've been building out features such as SSHing into your device. We've been internally, we're using a WireGuard network to kind of access everything, which feels like it's probably a pattern we should go and exploit as well. And a bunch of other features are exactly as Lance asked. So yesterday, we in fact went through a design session looking at what's the metadata that we need to put into the cloud console that's currently missing. One of those bits of metadata is eSIM profiles, which profiles are on it, which is active. Another one of those is a Linux device behaves very differently to a microcontroller. Predominantly, hundreds of thousands of microcontroller devices that go added to our platform. And of those, they all behave in a very kind of unique way. And the observability of the internals of them isn't that important, such as like, what's the CPU? What's the temperature? Like, these things don't necessarily overheat too much. Whereas on a Linux device, this Tachyon CPU, it's a cell phone CPU from a couple of years ago. If you know a cell phone, it can get pretty warm, especially if it's in your pocket or in direct sunlight. And it has to slow itself down at that point. And those are the kind of metrics that we're looking to capture automatically and then graph on the console side. So yes, the answer is the side of it. The other piece of it, I'm just trying to find Lance's comment. It says, are we looking into do things like A/B testing? Um, Yes, I don't think we've got quite that deep into Tachyon yet. As to currently, I'll say actually the what Particle does a lot of, and I'll say a lot of in like when I say it, we do a vastly more than you might think we do, is monitoring remote Linux boxes because that's how our platform's built. So we have a very large amount of team members that are highly accomplished at developing software, pushing them to remote hosts. I can safely say we've never seen one of the devices that our cloud operates on, and never will. So we only ever deal with these things remotely. So we've spent a lot of time both observing and also managing them. That is exactly the mentality that we're bringing into Tachyon, which is pretend that you will never see this device and it's somewhere in an unreliable state. How do we go and behave with it, and how do we monitor it and observe it? So that's kind of like the process we're taking to it, more of a cloud monitoring approach, because that is effectively what the world's also familiar with. Monitoring IoT devices is the misnomer, whereas monitoring a cloud data center is actually quite common.
Right. I think that's it's an interesting comment about what parts of our platform that has been built for microcontrollers translates over to Linux-based systems, um, either directly or with a little bit of futzing, or indirectly, and then where we need to sort of build from scratch. Because I think the overall we a lot of our platform carries over directly, right? Like the basic monitoring systems of like what you want to see when you're looking at a device, right? Of sort of basic like diagnostics, vitals, things like that. Obviously, there are concepts that are relevant in a Linux-based system, like monitoring, compute or RAM or something like that, that are not as relevant in an embedded system. But they're not diff. They're it's similar enough, right? That kind of infrastructure carries over directly. There's other things that are wildly different, like monitoring, deploying software to, controlling, logging into a Linux device, as opposed to a microcontroller, where like even saying logging into a microcontroller doesn't make any sense. There's no such thing to log into. But the skill set of our ISRE team, infrastructure and site reliability engineering, which is the people who manage our servers, is like very directly applicable to the for the tooling that for these distributed devices. So the um, looking at some of the other questions here. Luke is asking, is there any update on how data usage over 2 GB is going to be charged? Great question. No, we haven't worked through that yet. One of the things we're trying to figure out is how to get people a well-optimized plan, right? I think it's easier to figure that out in an enterprise context, because like if you're building a product with Tachyon and you're going to go to scale, we can more easily match the specific requirements of the plan to the specific device that you're doing and sort of do it at scale. In prototyping, we want to have it be kind of a menu of options and not be too complicated. And there's a couple ways to deliver on like smaller and bigger plans, which is it different profiles that you can select that have different fee structures, or is it more of an overages concept, and how do you deal with that? We haven't worked through a lot of those details, but it's on our list, of course, for things to make sure we figure out well. The Has any testing been done? That's going to be a Nick question on the DSI port.
Yeah, I can show you the board. Let me take another flip of my camera. Here we go. This is a DSI display, look, cell phone display specifically. That's what we're using. This here is what we call the big board. Um, where's a Tachyon board? I push all this stuff that way. If you think about Tachyon, got two sides to it. We just unfolded it, so you got the bottom and the top here, so it's easy to access, and we can put a lot more debug signals on it. And this is currently connected up with 2 ribbon cables. This one's connected to this camera over here, and then this one over here is connected up to this DSI display. What to say about the DSI display? Yes, it's a DRM device. It is configured through the device tree, so all of the DSI timings and things are inside of that. Have we experimented extensively with that one? Nope, not particularly. It works well. There's a couple of displays we've had working with it, such that we are confident that the interface is in good shape. The work needed to translate the DSI drivers over, I assume, is as simple as translating the timings from one driver to another one. I don't know whether the Qualcomm DRM driver for DSI requires any parameter tweaks or something. I've not attempted to go and do that. Somebody else has in the team played around with that. But yes, DSI display is working here. So that's how we're doing some of the testing at the moment. And then the cameras as well, we're using connected up to this Devo Brothers thing's just a, okay, I think my alien board. You can't see that, but it was the board that behaves in very mysterious ways. One time it looked like it powered itself on when it had no power due to a residual charge issue, which was fun.
The uh another question that I think we'll be excited to talk about, Nick. Any plans to implement suspend/hibernation to disk RAM and Tachyon? As far as I know, Raspberry Pi isn't implemented and Rockchip doesn't design it particularly well. Be a point of difference comparing with other SBCs. So I think like generally, maybe a good opportunity to talk about what we're doing with low power modes and because I know that has been a big focus of yours, is getting that stuff to actually work.
Yeah, I would say, first of all, there's another question about what's a CPU. So I'll grab that at the same time. So we're using a chipset from Qualcomm called the QCM 6490, which is uh, an 8-core ARM CPU from a couple of years ago, maybe 3 years ago now. You can still buy cell phones with it inside it. I think it's in the Fairphone 5. Is that the right model number?
It's in the Fairphone 5, and then the equivalent, it's a repackaging of prior smartphone silicon, which was the same. It's the same uh, IP under the hood as the Nothing One phone.
Right. So I'll start with that saying it is a cell phone processor. So one of the big differences between the work that Raspberry Pi does and the work that Qualcomm does is Qualcomm's focused on battery life. Is probably one of the most dedicated parts of their chipset, whereas Raspberry Pi has been focused on pushing the performance envelope. Um, and not to say that ARM architecture and stuff on the Pi isn't low power, but trying to keep the profile of the device to use the least amount of power possible hasn't been one of the goals that they've had. So what we found immediately from the Qualcomm chipset, without touching it, is that it is very power efficient. I guess I'm going to point again. We have several battery types. The one we're shipping with the Kickstarter um, has 3 cells on it. This one here is just a single cell version of it. That single cell lasted 2 days before I had to go and unplug it, sitting on my shelf, running back to back, or like not back to back, but periodic speed tests connected over 5G. What I'll take away from that is that the device is naturally low power. I have one of those battery packs that you put on a Raspberry Pi somewhere on my desk. It's like a cell phone style battery that goes onto a hat. I found that lasted, and it has a bit more energy than this device in it. And just for comparison, it took about 8 hours for that to drain on the Raspberry Pi from full charge. So we're somewhere, factor of 6, 8, 10 more efficient just out of the gate. And that's just a matter of, clock gating and automatic kind of power management. The Qualcomm chipset has a bunch of microcontrollers inside it. They're using the actually Hexagon DSPs, if anybody knows their Qualcomm architecture. And one of those is a chipset called the ADSP, which is in charge of doing things like USB power management, but also it observes all of the subsystems in the device and automatically turns off clock gates and things where they're not needed, just to bring the chip down to its lowest state. And then I'll jump to the question on the suspend to resume piece. Out of the box, the Linux distribution recognizes the push button on the side of it and will put it into a sleep mode. Now that is, it's following, because their Qualcomm chipsets were built around Android patterns. It follows the Android sleep mode, so it doesn't do a sus. It depends on the language here, because in the ACPI world, there's different versions of this. But what it does is it pauses. Oh, there we go. I'm terrible with my hands. We'll get the rainbows in a minute popping up. I don't know what they think
That
is
thing
the.
always turns on your
I don't
side.
know. I can't tell you how the rainbows work. There's a certain hand motion that causes them to cascade down. Um, the suspend mode here, what it does is it halts the CPU, allows interrupts to wake it up. It um, pauses. It does a self refresh on the DDR, so it keeps the DDR powered. The CPU is powered in very low power mode, and then you can wake it up with the push button, or there's a bunch of other interrupts that will wake it up. I think Wake on Network's one of them. Um, in terms of suspending it to disk so that you can truly hibernate it and like turn the power off, possible. I don't think we've looked into that so far. I think one of the tenets I think we would like to have on our device is that when it sleeps, it can be woken up through either Wi-Fi or cellular networking, so you can prod it. And that's typically how we run our microcontrollers as well. So I hope that answers the question.
Yeah. Uh, the I do think I just turned on my reactions. I think the peace sign was it. Maybe you have to hold it longer. There we go. There's
Oh,
blue
there we go.
ones. Yeah.
Peace.
The I'm gonna leave that on now. The actually, you know what? I think we can add both of us to Spotlight since we're kind of going back and forth. There we go. Okay. The uh Florian asks, are we going to be able to use our own eSIM? So I think Nick, that ties to what you were talking about at the beginning, but I think worth actually separating vocabulary. And I hate the eSIM vocabulary world because I'm gonna do my best to sort of separate the concerns. There is an embedded SIM chip on the product that is often called an eSIM, that has the functionality of being reprogrammable, which is also sometimes called an eSIM, but more properly called EUICC. Uh, and then there are profiles, meaning like you can get an eSIM profile, right? A SIM profile to deploy on the device. So I think the question is specifically, I don't think what that question was is can we put our own SIM card on it? But by which the answer is no, it uses the embedded SIM. But can we use our own SIM profile? So Nick, why don't you talk about that?
Yes, I think that is absolutely what we're planning to do. We use a sim platform from Keegan, um, which is, there's a bunch of vendors out there, but Keegan is the one that we uh, found most like good support from, and their technology just worked. Um, there's a couple of things in the world of eSIM. Primarily, I guess we're talking here about local SIM profile installation, so that you can paste in a eSIM profile link, an RSP link, if you so wish, into the device, and it will install it. Yes, I think that's a thing we'll absolutely support. It comes with caveats, as we're finding out. That's what I was playing with testing when I was just starting here. Um, Depends on the kind of eSIM plan that you've got. So some of those eSIM plans, which are like the very, very low cost ones that you get, have restrictions on them in terms of device types you can use, and you have IMEI filters on them. So I think what Particle is going to say is your mileage may vary, um, and experimentation is highly welcome. The SIM we're providing on the platform, we're making sure that has kind of global roaming on it, has an affordable data fee on it, and we're making sure that it has low latency, that we can keep the throughput up, that as long as you put a credit card in or however we're charging on the platform, it'll just keep going and ticking up. I think that there is value in that from a it just works perspective. But I think on the eSIM side, we'll support it, but you'll be managing your own connection, which just comes with a bunch of like some people are very happy to do that.
Yeah. And in general, I think our hope is that our profile, the off-the-shelf profile, is we sort of are starting with like a single profile, uh, with one envelope of data, and there are many reasons why it makes sense to have other profiles, right? Different cost structures, different native connections to carriers. There are things like, the FirstNet network for AT&T. So if you're doing an application uh, that is for first responders, they get priority on the network, things like that. There's lots of ways to like optimize against a particular profile. And so, of course, that's where experimentation is welcome. We also intend to expand the set of sort of supported profiles in there over time once we have a sense for what people need, right? Because we can go and get them, and if we get them and we put them in, then we can also make sure it actually works, and have it be well tested. So, um, I think that's also indicative of generally how Particle operates, and it will operate with Tachyon, which is that we're when we look at a Linux-based system, this is true for our microcontrollers too. Um, we want to create a really great happy path, and say there's a way of doing things that we've built out here, and we can really stand behind how well it works, but also not force people into it, right? I think we earn people's use of our technology by making it really good, rather than by requiring that you use it that way as opposed to doing other things. And so, for instance, like it runs Linux in principle, the chipset supports things like Android and Windows, and we would love to get around to adding those as first class citizens on the platform. It'll probably be a minute before we have a chance to do that. And so, in the meantime, I expect that people are going to try it themselves, and that's great, right? Because A, if that's what you need, go for it. And B, in the meantime, all that experimentation, right? If folks discover really great, that like it's really usable in these kinds of environments, cool. We can pull that in as something we support directly. And so we're very excited for all that experimentation. And I'll come back. Dan had a couple questions that I'll sort of highlight because I think the some of the questions are on like Particle Device OS. So Particle is about to get a little confusing because we have historically supported microcontroller products that have different chipsets in them and different, processors of different generations. But there's a single software stack that we created that created cross compatibility and represents the quote unquote operating system of that product, an RTOS, of course, because these are microcontrollers, called Particle Device OS. Device OS will not does not exist in the context of the Linux-based devices. Well, it sort of does. We have an agent that runs on the device, called Particle D, that will be our sort of daemon that is what allows us to do remote monitoring, things like that. All those services rely on the daemon. And Nick, I don't know how like closely related at this point are Particle D and Device OS.
Oh, they're separate projects completely. They use a different communication protocol, a different security
Okay.
stack. They egress into the same cloud platform, but there's maybe there are distant cousins.
Okay. The But then the OS here will be Ubuntu. Um, and I don't know if I mean we start to get into trademark and branding stuff, but like how Nick, would you describe that? How unique would that you describe that Ubuntu? Like, would we call it Particle Ubuntu, or is it um
I'm
uh
referring to it as the Ubuntu major release at the moment. So like 20.04, 22.04, 24.04, kind of like sticking onto the LTS. So that's the way we're describing it. We're not how Ubuntu works is you have a base release, which is one of those major versions. And then on top of it, you can add in some OEM customizations onto the image that flashed onto it. So an example would be some PC vendors can use a generic image, but you can also download a customized image that installs drivers for that platform that are non-standard. So we'll have a version of Ubuntu with some non-standard platform additions into it, just because the ARM mainline for Qualcomm chipsets isn't that mature at the moment. Otherwise, you could get away with a vanilla one.
yeah.
And yes, I guess that's what we call it internally. We don't have an OS brand for that.
Cool. Dan asks, how long will we be manufacturing these boards? Any expected EOL? The So our history with like device lifetimes has generally been as we will make things as long as we can make them based on the availability of the components inside and the existence of commercial demand for that product. So if we go back in the history of products, Spark Core We deprecated at the point at which basically nobody was buying it anymore because it had been displaced by a superior product. And no one ever launched products at scale with Spark Core. Everything we created since then, that was our Gen 1 microcontroller product. Everything we created since then, we essentially have made as long as there were customers for it, or as long as we could. The silicon shortage and which the of 20 whatever that caused some disruption in the silicon market that meant that certain chipsets that we were using stopped existing essentially. And so other than that event, we have generally made things as long as essentially based on the lifetimes of the components within. Um, the uh, the QCM 6490 is one of the things that's interesting about it is that it is a product with a very long guaranteed lifetime, because essentially, for all intents and purposes, the lifetime of Tachyon is gated by the lifetime of the QCM 6490. And while it is the same or very similar silicon to prior smartphone chips, smartphone silicon has very short, goes out of style real fast. And so Qualcomm has committed to, I think it's a 10-year lifetime from when they started it. So it's probably at this point, I think it's guaranteed until 2030, like four, maybe something like that. Nick, do you know that off the top of your head?
36, I believe, for this
Okay.
chipset.
Oh, so this one's a little longer than their 10-year. They have
Yeah.
a IoT portfolio of chips that they're making that are sort of anywhere from 10 to 15 years. And so, which is good. So it means we'll be able to make this thing for a while. Michael's asking what use cases appear most often amongst early adopters. Um, I think we did some surveys and asked folks what we're working on, what they're working on. It's definitely broad. I would say um, one of our questions was if we look at the single board computer market versus the microcontroller market, our microcontroller business has always been very diverse in that, um, of our 175 enterprise customers, I think there's probably 160 use cases. So there is some doubling up, but it's mostly sort of one for one, and very, very broad. There was a question we had looking at this market: is this going to be similar or different, or how's it going to be shaped? And I do think there's more patterns of clear spikes. So I'd say the ones that have emerged at this point, think like generally cameras, drones, robotics, and vehicles are some of the things that we've seen. Not just people with intent for development, um, but like actually planning on scaling out a product with it. But it's early days. I don't know how much, we'll see how that holds once it's shipping at scale and people have actually had a chance to work with it. I think as far as like, developers, um, the, my read on the survey results was it feels a lot like, um, I think that I'll put it this way. There are, I think of two things that are most distinctive about this thing. One is that it has a 5G connection. One is that it has an AI accelerator. There's other aspects of it, but like I think there are there are definitely people for whom the purpose of this is like, okay, cool, it's a cellular Raspberry Pi, and there are other people for whom it's like, oh wow, this is a very powerful Raspberry Pi. And there are plenty of people for whom it's like, oh great, I need both a cellular connection and a very powerful Raspberry Pi. Right? Those are like the categories. And um, I don't know if we've quite broken it out, but it's broad. Um, Let me go back and see what I missed earlier. We're coming up on 10 minutes left, so folks, you got other questions, just feel free to pop them in. RF bands and countries to the modem support. Uh, Nick, quick list off every RF band frequency.
A sheet, I think, on a Kickstarter. There's two versions of it. The North America version is Canada, America, Mexico, but bizarrely includes quite a lot of other bands, including China, one of the bands over there. Anyway, it's a bit of a mixed bag. And the other version we're selling is the rest of world, which pretty much does the other countries. One of the hugely fun parts of this project is 5G requires, this thing's got 5 antennas on it. Um, and each of those uses kind of like a subset of different bands and such. And so one of the jobs we'd had to do was combining them all together into like a big old spaghetti mixture. We only have one antenna that goes onto it, but the module is switched out. There's two versions of the module, one for North America, which kind of connects in a lot of places, and one in the rest of the world, which doesn't connect to North America. So that's a differentiation for the rest of the world. It doesn't connect in my house, whereas the other one does.
The I think I think this is the only cellular connected single board computer. Somebody might like there's probably things out there that could be classified as cellular connected single board computers, but to my knowledge, there isn't one that's just like out there. And I think that's a big part of what we wanted to do with this is just make that ability to do it to create something cellular connected kind of as easy as having a smartphone. And some of that is sim profile kind of stuff, right? Just oh yeah, I can just swipe my credit card and get a subscription. A lot of it is technical, right? That antenna is Nick, how would you stack rank that antenna in terms of from a hardware perspective, like technical complexities of this product versus like other things that are also complicated, like the power, like the power system.
I would say that I'll just give you my experience because I'm a huge fan of making LDS antennas. The last time I built one, it took 63 iterations to get there. Around iteration 30, all hope and interest had completely gone. Um, and just regular beatings were applied until it got to the point where it was good. With this one, we seem to have hit gold very early on in. And I said, now it's going to require how many more gentle beatings are needed just to fix that little tweaks to it. So this one has been quite painless. I'm almost giddy with like, we should put like 50 of these down onto every product. But what will happen is this was an outlier. And in general, designing antennas in a simulator, printing them and then getting them to work is a very long, laborious process. But I've been pretty happy with this one. So.
I think knowing that history is funny, given that when we first started doing this, I felt like it was an excuse for you to do one of those antennas, which you
Yeah, I
seemed
do
very excited
honestly.
about.
That's exactly what it was. Immediately, I was like, "Oh, I've got PTSD from doing it before. It was so much fun."
Right. Surprising that you signed up for it again. The but awesome that it works. I do think that antenna is really cool, and it's there's I mean the fact that like there's some things that I think our engineering team should be very proud of about the design of it. Like, oh, we found this. Like, where the hell do you put a giant 5G antenna on a Raspberry Pi? Oh, well, we did USB-C, so we can use up all the space that's available, that's made available when you don't have the little stack of sort of boxes that are on the end for ports, right? And so a lot of clever design went into even figuring out how to get that thing onto the board in the first place and still maintain compatibility with that ecosystem, right? Because that's um, we have to fit into a certain envelope in order to be able to do it. Um, and then and then there's the like, I mean, there's a whole sort of certifications thing, right? Which is the other thing that I think is probably why there aren't other cellular single board computers because um, once you have a functional thing with a cellular connection on it, then you need to deal with certifications, and certifications are big and complicated and nasty and kill projects. And so this has been something that Particle has done for a long time. Uh, um, we've been good at dealing with certifications. Dan is asking, are all board versions FCC certified? We'll come back to that. Gamma and later, yes, but the beta will not be. We've been doing FCC and equivalent international certifications since the Spark Core in 10 years ago. Cellular certifications add a whole nother level because you have to have the same certifications, and then you also need carrier certifications, PTCRB certifications, depending on what SIM card and data plan go in there. And so that's a whole nother thing. And those are really expensive and slow and complicated. And so, the handling certifications on customers' behalf and also making it so that their products are easily certified is a big uh, goal there as well. So maybe Nick, worth talking a bit about certs, your other
Yeah.
favorite.
Currently imported under a waiver that allows us to import limited number of devices. We have pre-scanned this device. Bizarrely, on the cert side, it passed on the first go, which again, just touching lots of wood and just gasping. One of the dangers of tweaking that antenna is that it breaks something inside of that, because certification is very expensive to go through, and also even the pre-scanning is laborious when you've got so many bands that we have on here. But yeah, in fact, I think one of the things I thought we wouldn't be capable of doing was hitting PTCRB, which is, if anybody knows, is one of the standards that operators themselves require if you go native. For example, if you put our device onto a native Verizon SIM, they don't allow that device on unless you have passed a standard called PTCRB and registered the IMEI of your device with the operator. I didn't think we're going to hit that. We've been shying away from it, and the first time we tried to do it, it blew past the threshold needed, and straight into kind of glory category. So again, I'm suspicious. At the moment, I think there's more work needed on the antenna. We do need to improve, like, or whether maybe I should just move house, right? So a place where band 71 isn't the primary connectivity for T-Mobile. And then maybe I wouldn't fuss about it. But I do think there's a little bit more tweaking done to it just to go and push it to be amazing. Currently, it's great. I'd like it to be excellent or like top 5 out of 5.
Right. And these are the things that we can only really do once because it's not like we can't iterate on this stuff because of certs, right? So like if we have something that we think of as good, but maybe not great, there's other things you can imagine iterating on the design after initial release and saying like, okay, each version after that will be better. But when it comes to certs, well, if we change anything, then we lose our certs. So the um so we got to get it right out of the gate. But yeah, it's these are all complexities that we don't want customers to have to deal with. Whether you're doing it in single units, right? Like developers with a single board computer for a home project, like not a thing you want to deal with. And but also deploying at scale, right? Like the reality is nobody really wants to have to like invest the time and energy to do that kind of stuff. And so we want to make it uh, simpler. So we're at time. And so I want to thank everybody for joining today. And uh, Nick, thanks for going through and showing it off. Um, we've got 40 people on now, so we had a good crew show up. Thank you for all the questions. We are as we start to get the product released and start to get alpha units out, I think the next step will be something we want to do a little bit more working in public. And so we haven't, I wouldn't say we have specificity on what that means yet, but there's a lot of good stuff to come. And I appreciate we have more than enough volunteers for the alpha, so we'll oh, somebody asked how you do that. You just go make a comment in that Kickstarter. We haven't reached out to folks yet, so you can still do it. Go make a comment on the Kickstarter update that asked for alpha participants. But there were some good comments there. People talked about their experience and some of the things they could help with, and I really appreciate the like willingness and eagerness to help with some of the bits and pieces of this that are going to be. We're glad for the help. So and then Beto, we'll get to do that, some version of that with a broader crew. So thanks for joining, everyone. Thanks Nick for chatting. Thanks to all the other Particle people that are on here and the engineers that are working on all this, because obviously we're talking about your work. And it's good work. It's a cool product. So more to come.
So everyone, there's some great questions. Really appreciate it. No balloons. God.
Oh, we got hold on. Yeah, wait.
Somehow.
I think you just gotta hold it for a little while.
I got an upgrade.
Wait, what did you do to get the confetti?
I don't
What
know.
was
I don't know. If I figure it out, then the magic goes. So
Oh, there we go. All right. Later, folks.
okay, thanks, folks. Bye.